Look around you right now. Touch the table beside you, feel the chair you're sitting on, look at your hands moving in front of your eyes. Everything seems solid, real, undeniably there. You exist in this moment, in this space, as a conscious being experiencing reality. But what if I told you that one of the greatest physicists who ever lived, Richard Feynman, discovered something so profound about the nature of existence that it challenges everything you think you know about what it means to be? What if the very concept of where and how you exist is not what you imagine it to be? Imagine for a moment that you're sitting in a coffee shop watching people walk by the window. Each person seems like a solid, continuous entity moving through space. You see them approach from the distance, pass by your window, and disappear around the corner. In your mind, there's no question that these people exist as coherent, unified beings occupying specific locations at specific times. This seems like the most obvious truth in the world. But Feynman's revolutionary insights into the quantum nature of reality reveal that this obvious truth might be the most beautiful illusion ever conceived by the human mind. Picture yourself as a child, building with blocks on the living room floor. Each block was solid, dependable, occupying its own space. You could stack them, count them, move them around. The blocks existed in a way that made perfect sense to your young mind. They were there or they weren't there. They were in one place or another place, simple, logical, comforting in its certainty. But as you grew older and learned about atoms, you discovered that those solid blocks were mostly empty space, with tiny particles whizzing around at incredible speeds. Still, the particles themselves seemed real enough. They had mass, they had charge, they followed predictable laws. Even when you learned that atoms were mostly empty space, you could still imagine tiny solid particles orbiting around tiny solid nuclei, like planets around miniature suns. But then Feynman came along and shattered even that comfortable picture. Through his groundbreaking work in quantum electrodynamics, he revealed that even those fundamental particles, those supposedly solid building blocks of reality, don't exist in the way you think they do. They don't have definite positions. They don't follow definite paths. They exist in a strange, ghostly state of possibilities, only becoming real in the sense you understand reality when they interact with something else. And here's where it gets truly mind-bending. You, sitting there reading these words, are made entirely of these ghostly, probabilistic entities? Every atom in your body, every electron, every photon of light hitting your eyes right now exists in this same strange, distributed way. When you ask the question, "Where do I exist?" you're assuming that you are a thing that can be located somewhere. But Feynman's work suggests that this assumption itself might be fundamentally flawed. You're not a thing in a place. You're not even a collection of things in places. You're something far stranger and far more beautiful than that. You're a pattern of possibilities, a dancing constellation of probabilities that only seems to exist as a unified entity because of the way information flows and integrates across the quantum fields that make up your being. The very question of where you exist might be like asking where the color blue exists or where the music exists when an orchestra plays a symphony. Have you ever really stopped to think about what makes you you? Is it your body? But every cell in your body replaces itself every few years. Is it your thoughts? But your thoughts change constantly, flowing like a river that never contains the same water twice. Is it your memories? But neuroscience shows us that memories aren't stored like files in a computer, but are reconstructed each time you recall them, changing slightly with each reconstruction. So where exactly do you exist? This question might seem abstract, philosophical, the kind of thing that university students debate late at night, but that doesn't really matter for practical life. But Feynman's discoveries reveal that this isn't just a philosophical puzzle. It's a fundamental question about the nature of reality itself, and the answer has profound implications for how we understand consciousness, identity, free will, and our place in the universe. The way you think about your own existence shapes everything from how you make decisions to how you relate to other people, to how you understand your mortality. I want you to pause and think about something that seems simple. Right now, as you're reading this, where exactly are you located? Are you in your head looking out through your eyes like you're piloting some kind of biological robot? Are you distributed throughout your body, somehow present in every cell? Are you floating somewhere above your body, observing it from the outside? When you really examine this question closely, you'll find that the obvious answers start to seem less obvious than they first appeared. Let me take you on a journey that begins with a simple observation and ends with a complete transformation of how you understand your own existence. We'll start with something Feynman himself loved to contemplate, the strange behavior of light. But we're not just talking about any light. We're talking about the light that's hitting your eyes right now, carrying the information that allows you to see these words. Every photon of that light exists in what Feynman called a superposition of all possible paths from its source to your eye. It doesn't take just one path, like a ball thrown through the air. It doesn't even take multiple paths, like water flowing through different channels. It exists in a ghostly state where it's simultaneously taking every possible path, and only when it hits your retina does it choose which path it actually took. But here's what will really shake you. The electrons in your retina, the ones that are right now converting those photons into electrical signals, exist in the same strange way. They're not little balls sitting at specific locations waiting for photons to hit them. They're probability clouds, existing in multiple places simultaneously until the moment of interaction forces them to decide where they are. And those electrical signals traveling up your optic nerve to your brain? The electrons carrying those signals also exist in this quantum superposition, this ghostly state of all possibilities. So the very process by which you're becoming aware of these words involves particles that don't have definite locations until the moment they interact with other particles that also don't have definite locations. Your conscious experience of reading right now emerges from an intricate dance of particles that exist nowhere in particular until they exist everywhere in particular. It's as if reality is constantly creating itself, moment by moment, through an endless series of quantum interactions. Now think about this from the ground up, and let me show you how Feynman revolutionized our understanding of this process. In the 1940s, physicists were struggling with a fundamental problem in quantum mechanics. They could describe individual particles and their behavior, but when they tried to understand how particles interact with electromagnetic fields, the mathematics broke down. The equations gave infinite answers, which makes no sense in the real world. It was as if the theory was saying that every interaction between matter and light should release infinite energy, which clearly doesn't happen. Enter Richard Feynman, a young physicist with an unconventional approach to thinking about quantum mechanics. Instead of trying to fix the mathematical problems by adding more complex equations, Feynman stepped back and asked a more fundamental question. What if we're thinking about particles and interactions in completely the wrong way? What if particles don't follow single, definite paths through space and time, but instead follow every possible path simultaneously? What if reality isn't made up of things moving from one place to another, but rather patterns of probability that span across space and time? Feynman developed what became known as the path integral formulation of quantum mechanics, and with it, he created a new language for describing reality: Feynman diagrams. These elegant, simple drawings show particle interactions not as collisions between solid objects, but as exchanges of virtual particles that exist only in the fleeting moments of interaction. A virtual particle is neither real nor unreal, neither existing nor not existing. It's something in between, a quantum ghost that mediates the forces between real particles. But here's the truly revolutionary part. In Feynman's formulation, the distinction between real and virtual particles becomes much less clear than you might expect. Every particle can be thought of as virtual when it's not being observed or measured. Every real particle becomes real only through its interactions with other particles. Reality, in Feynman's view, is not a collection of things, but a web of relationships, a network of interactions between entities that have no definite properties until they interact with other entities. What are your thoughts so far? Does this challenge your intuition about what's real and what's not? I'd love to hear in the comments how you're processing these ideas. Do you find them unsettling, exciting, or maybe both? The rabbit hole we're exploring goes much deeper, and your perspective matters as we dive into even stranger territory. This brings us to one of the most profound implications of Feynman's work: the realization that the question, "Where do you exist?" might be fundamentally misguided. You see, when Feynman worked out the mathematics of quantum field theory, he discovered that particles aren't really particles in the way we normally think about them. They're excitations in underlying quantum fields that permeate all of space and time. An electron isn't a tiny ball of matter, it's a particular pattern of excitation in the electron field. A photon isn't a little packet of light, it's an excitation in the electromagnetic field. This means that you, right now, aren't really made of particles in any conventional sense. You're made of interacting field excitations, patterns of energy and probability that dance across the quantum fields that fill the universe. The electron field that contributes to making up your body extends throughout the entire universe, and the patterns that correspond to your electrons are just localized excitations in this universal field. In a very real sense, you don't exist in a particular place so much as you exist as a particular pattern that emerges from the interaction of universal fields. Feynman himself was deeply struck by this realization. In his famous lectures on physics, he often returned to the theme that our everyday experience of solid, separate objects is a kind of collective illusion created by our limited ability to perceive the quantum world directly. He would often say that if you really want to understand nature, you have to abandon your intuitive notions about how things work and learn to think in terms of probabilities, fields, and interactions rather than solid objects moving through space. But Feynman went even further than this. Through his work on quantum electrodynamics, he discovered something even more startling about the nature of time and existence. In the quantum world, particles can move backward in time. This isn't science fiction. It's a fundamental feature of quantum field theory that Feynman used to solve some of the most difficult problems in physics. A positron, the antimatter counterpart of an electron, can be thought of as an electron moving backward through time. When matter and antimatter annihilate, creating photons, you can think of it as a single electron bouncing backward and forward through time, appearing to us as two particles that come together and disappear. This means that the timeline of your existence isn't the straightforward progression from past to future that you experience subjectively. At the quantum level, the particles that make up your body exist in a complex web of interactions that span backward and forward in time. Some of the quantum events that contribute to your existence right now are connected to events that will happen in the future, just as they're connected to events that happened in the past. Your existence isn't confined to this moment in time any more than it's confined to this particular location in space. Feynman's insights reveal that when you ask, "Where do I exist?" or else, you're making several assumptions that quantum mechanics shows to be questionable. You're assuming that you are a discrete entity separate from the rest of the universe. You're assuming that existence means being located at a particular place and time. You're assuming that the boundary between you and not you is clearly defined and meaningful. But quantum field theory suggests that these assumptions, while useful for navigating everyday life, don't correspond to fundamental features of reality. Consider this. Every breath you take contains atoms that were once part of stars that died billions of years ago. The carbon in your body, the iron in your blood, the calcium in your bones, all these were forged in the nuclear furnaces of ancient stars and scattered across the universe when those stars exploded. In a very literal sense, you are made of stardust, but it goes deeper than that. The quantum fields that give rise to the particles that make up your body are the same fields that gave rise to those ancient stars. You're not just made of recycled stellar material. You're a temporary pattern in the same underlying quantum fabric that has been creating and destroying patterns for billions of years. The water in your body has been part of clouds, rivers, oceans, other living creatures, and countless other forms over the history of the Earth. The atoms in your body are constantly being exchanged with your environment through breathing, eating, and metabolic processes. From a purely physical perspective, the boundary between your body and the environment is much more fluid than it appears. You're not a thing in the world so much as you are a process, a pattern of energy and information that maintains its coherence while constantly exchanging matter and energy with its surroundings. But Feynman's insights go beyond even this physical picture. In quantum mechanics, the act of measurement or observation plays a fundamental role in determining what becomes real. Before a quantum system is measured, it exists in a superposition of all possible states. The measurement process doesn't just reveal which state the system was in. It actually determines which state the system ends up in. This is the famous measurement problem in quantum mechanics, and while physicists debate its implications, there is no question that it fundamentally challenges our naive ideas about objective reality existing independently of observation. This raises a profound question about your own existence. To what extent does your existence depend on being observed or measured? Your consciousness involves constant measurement and observation of your internal states and your environment. Every moment of conscious experience involves your brain making measurements of sensory input, internal emotional states, memories, and thoughts. In a sense, your existence as a conscious being might be intimately connected to the quantum measurement process. You might not just be made of quantum systems. You might be a quantum system whose existence depends on the constant process of self-measurement and self-observation that we call consciousness. Feynman was fascinated by the relationship between physical processes and consciousness. Though he was characteristically careful about making claims beyond what could be rigorously demonstrated, he often pointed out that consciousness involves the flow of information through complex networks, and that this information processing must ultimately be grounded in physical processes. But he also recognized that we don't yet understand how the subjective experience of consciousness emerges from objective, physical processes. This is still one of the hardest problems in science and philosophy. What we can say is that your sense of being a unified, continuous self existing at a particular location is constructed by your brain from countless separate pieces of information. Your brain takes input from your senses, your memories, your emotional states, and your thoughts, and weaves them together into the seamless experience of being you, existing here and now. But neuroscience shows us that this seamless experience is actually constructed from many separate processes happening in different parts of your brain. There's no single location in your brain where you exist, just as there's no single location in space where your quantum field excitations exist. So where do you truly exist? Feynman's answer would be that you exist wherever and whenever the patterns of information and energy that constitute your being have effects on the world. You exist in the quantum fields that span the universe. You exist in the complex web of interactions between the particles that make up your body. You exist in the flow of information through your nervous system. You exist in the memories held by people who know you. You exist in the effects your actions have on the world around you. You exist in the words you speak and write that influence other minds. You exist in the love you give and receive that creates bonds between conscious beings. From this quantum perspective, your existence is not confined to the boundaries of your physical body or limited to the present moment. You're part of an intricate web of relationships and interactions that extends across space and time. You're a pattern in the universal quantum fields that temporarily achieves self-awareness and the ability to affect other patterns. Your existence is both more fragile and more enduring than you might have imagined. More fragile because the pattern that is you is constantly changing and could be disrupted in countless ways. More enduring because the effects of your existence ripple outward through space and time, influencing other patterns in ways that can persist long after the particular configuration of quantum fields that constitutes your body has dissolved and reformed into new patterns. This perspective doesn't diminish the reality of your existence, it enriches it. You're not less real because you're made of quantum fields rather than solid particles. You're not less significant because your existence is temporary and interconnected rather than permanent and separate. If anything, the quantum nature of reality makes your existence more remarkable, not less. You're a pattern of incredible complexity and beauty that has emerged from the fundamental fabric of reality itself. You're a way for the universe to experience itself, to become aware of its own existence. FEYNMAN often emphasized that the universe is far stranger and more beautiful than our everyday experience suggests. The solid, separate objects of our ordinary experience are like shadows cast by the deeper quantum reality. When you understand that your existence is grounded in this deeper level of reality, where everything is interconnected and where the boundary between observer and observed becomes blurred, you begin to see yourself not as an isolated entity struggling against an alien universe, but as an integral part of the cosmic process itself. Your consciousness, your thoughts, your experiences, your relationships, all of these arise from and participate in the same quantum processes that govern the behavior of stars, galaxies, and the entire universe. You're not in the universe, you are the universe, at least a small part of it that has become aware of itself. When you ask, where do I exist? The answer is, everywhere that the effects of the quantum patterns that constitute your being extend, which is potentially everywhere in the universe, across all of time. This understanding doesn't solve all the mysteries of existence, but it opens up new ways of thinking about who you are and how you relate to the world around you. It suggests that the boundaries you normally draw between self and other, between mind and matter, between past and future, are more fluid and arbitrary than they seem. It invites you to consider that your existence is both more temporary and more eternal than you might have thought. If you found this exploration of quantum reality and consciousness as fascinating as I did, please consider liking this video and subscribing to the channel for more deep dives into the mysteries of physics and philosophy. The journey we've taken together from the simple question of where you exist to the quantum nature of reality itself reveals something profound about the nature of scientific discovery. We started with what seemed like an obvious truth that you exist as a solid, separate entity in a particular place and time, and ended up discovering that reality is far stranger and more interconnected than our everyday experience suggests. This is the power of physics. It doesn't just give us new technologies, it gives us new ways of understanding our place in the cosmos. Feynman's great insight was that we shouldn't expect reality to conform to our intuitive expectations. The universe doesn't owe us the comfort of familiar, easy-to-understand concepts. Instead, reality is what it is, regardless of whether it matches our preconceptions. Our job as conscious beings is to adjust our understanding to match reality, not to insist that reality match our understanding. This requires intellectual courage and humility, a willingness to let go of cherished beliefs when evidence points in new directions. The question of where you exist turns out to be a gateway into some of the deepest mysteries of physics and consciousness. It connects to questions about the nature of time, the role of observation in quantum mechanics, the relationship between mind and matter, and the ultimate fate of information in the universe. These aren't just abstract academic puzzles, they're questions that go to the heart of what it means to be a conscious being in a quantum universe. When you truly understand that your existence is grounded in the same quantum processes that govern all of reality, it changes how you see yourself and your relationship to everything else. You're not a stranger in a strange land. You're an integral part of the cosmic story, a temporary arrangement of quantum fields that has achieved the remarkable feat of self-awareness. Your thoughts, your experiences, your capacity for love and wonder and curiosity, all of these emerge from the deepest level of physical reality. You are the universe thinking about itself, questioning its own nature, seeking to understand its own existence. This is perhaps the most profound answer to the question of where you exist. You exist wherever consciousness touches the quantum fabric of reality and says, I am here, I am aware, I am part of this magnificent cosmic dance. Pause. In that moment of recognition, the boundary between you and the universe dissolves, and you realize that the question of where you exist has been transformed into a celebration of the fact that you exist at all. Note, this content combines established scientific principles of quantum mechanics and quantum field theory with educational interpretations and philosophical reflections for entertainment purposes. While the scientific concepts discussed are real and well established, some of the connections drawn between quantum mechanics and consciousness remain areas of active research and debate in the scientific community. But let's push even deeper into this rabbit hole, because Feynman's insights about existence become even more mind-bending when we consider the experimental evidence that supports them. In 1909, decades before Feynman's revolutionary work, a physicist named Geoffrey Taylor performed an experiment that would forever change how we think about the nature of reality. He dimmed a light source so much that only one photon at a time passed through his experimental apparatus. These individual photons were then directed at a screen with two slits cut into it. According to our everyday understanding of reality, each photon should go through one slit or the other, just like a tiny ball would. But what Taylor discovered defied all common sense. Even when only one photon at a time passed through the apparatus, an interference pattern still appeared on the detection screen. This pattern is the same kind you see when waves interact with each other, creating regions of brightness where wave peaks align and regions of darkness where peaks cancel out troughs. But how can a single photon traveling alone create a wave interference pattern? The only explanation is the one that Feynman later formalized mathematically. Each individual photon somehow passes through both slits simultaneously, interfering with itself to create the pattern. The photon exists in what physicists call a quantum superposition, a ghostly state where it's simultaneously taking every possible path from the light source to the detection screen. It only chooses a definite path when it hits the detector and is forced to appear at a specific location. Now here's what should absolutely blow your mind. This isn't just true for photons. Modern versions of this experiment have been performed with electrons, atoms, and even large molecules containing dozens of atoms. In 2019, scientists successfully demonstrated quantum superposition with molecules containing over 2 Serdudsust atoms. Each of these complex molecules existed in multiple places simultaneously until the moment of detection forced them to choose a single location. You might think this is just a quirky property of very small things that doesn't affect your everyday existence, but you'd be wrong. Every chemical reaction in your body, every firing of neurons in your brain, every process that keeps you alive and conscious depends on quantum mechanical effects. The very fact that atoms can form stable molecules is a quantum mechanical phenomenon. The enzyme reactions that power your metabolism work through quantum tunneling, where particles pass through energy barriers that should be impossible to cross according to classical physics. Your sense of smell depends on quantum effects in the proteins in your nose that detect odor molecules. The photosynthesis that powers the plants that produce the oxygen you breathe uses quantum coherence to transport energy with near-perfect efficiency. The magnetic field navigation that guides migrating birds may rely on quantum entanglement in proteins in their eyes. You're not just made of quantum systems, you're constantly relying on quantum processes for your moment-to-moment survival. But perhaps the most startling implication of Feynman's work involves what physicists call quantum entanglement. When two particles become entangled, they remain connected in a way that transcends our normal understanding of space and time. Measuring one instantly affects the other, regardless of how far apart they are. Einstein famously called this spooky action at a distance and refused to believe it was real. But experimental tests have confirmed beyond any doubt that quantum entanglement is a genuine feature of reality. Here's the profound part. The particles that make up your body were created in processes that involved countless quantum entanglements. The hydrogen atoms in your body were formed in the first few minutes after the Big Bang, when the universe was a hot, dense soup of quantum particles. The heavier elements were forged in the hearts of stars through nuclear reactions that created vast webs of quantum entanglement. When those stars died and scattered their contents across the universe, the quantum correlations persisted. This means that you are quite literally entangled with the rest of the universe. The quantum fields that give rise to the particles in your body maintain subtle correlations with quantum fields throughout the cosmos. Every measurement, every interaction, every moment of your existence participates in the universal quantum network. You're not just in the universe, you're quantum mechanically connected to it in ways that transcend the ordinary boundaries of space and time. Modern technology is beginning to harness these quantum effects in remarkable ways. Quantum computers use superposition and entanglement to perform calculations that would be impossible for classical computers. Quantum sensors can detect gravitational waves rippling through space-time itself. Quantum communication systems use entanglement to transmit information with perfect security. These technologies work because they embrace the strange, non-classical nature of quantum reality rather than trying to force it into classical concepts. What does this mean for your understanding of your own existence? It suggests that the boundary between your consciousness and the physical world is far more permeable than you might imagine. Your thoughts and perceptions emerge from quantum processes in your brain that are intimately connected to the quantum fabric of reality itself. When you observe the world around you, you're not a passive witness to external events. You're an active participant in the quantum measurement process that helps determine what becomes real. This participatory universe concept, explored by physicists like John Wheeler, suggests that consciousness and physical reality are not separate domains but different aspects of the same underlying quantum reality. Your existence as a conscious observer isn't just embedded in the universe. It's an essential part of how the universe creates and maintains itself. Every moment of awareness, every conscious observation, every decision you make participates in the ongoing creation of reality itself. So when Feynman's answer shakes your identity, it's not destroying something real and replacing it with something illusory. It's revealing the deeper reality that was always there, hidden beneath the surface appearances of ordinary experience. You exist not as a separate, isolated entity, but as a conscious pattern in the universal quantum field, forever connected to and participating in the cosmic dance of existence. This understanding doesn't diminish your significance, it reveals your true cosmic citizenship in the most profound way imaginable.